guys, welcome back to the final installment for simple harmonic motion, number 5. The graph below, or rather in this case to the right, shows two examples of simple harmonic motion, labeled A and B. For each, what is A, the amplitude, B, the frequency, C, the period, and D, write the equations for both A and B in the form of a sine or cosine. Okay, so this is periodic motion, right? I mean, they both look like cyclical functions. They're repeating their pattern over and over again. So for part A, the amplitude. So by definition, to find the amplitude of a function, you take the maximum point, you take the minimum point, you add the two absolute magnitude distances together, and you divide by 2. In this case, the amplitude is just the distance from this horizontal axis to the maximum point. So that is A. And it should be the same in both directions. Okay, so in this case, A, the amplitude for curve B is 3.5, and for curve A, it is 2.5. Okay, so the amplitude for A is 2.5 meters, and the amplitude for B is 3.5 meters. So that's done. So now, B, the frequency. When you're looking for frequency, you have to ask yourself, how many cycles does the graph finish every second? Or how many cycles for how many seconds? Okay, so for example, for A, take a look at A. It's only doing one cycle in this diagram, and it's taking it 4 seconds. Okay, so for A, we would say one cycle takes 4 seconds. Okay, 1 divided by 4 is 0.25, or 1/4. So 0.25 cycles per second, which is the unit hertz. Okay, for frequency. So this is a frequency of A. Now for B, you do the same thing. For B, one cycle, for it to go back to its original spot, takes 2 seconds. So we're going to say one cycle, 2 seconds. So 0.5 hertz. That's FB. Okay, now part C, the period. Now there's 2 ways you can find the period. First, you ask yourself, how long does a cycle take? How many seconds? And the other is, well, I already found frequency, and I know the relationship F is equal to 1 over T. Therefore, T is equal to 1 over F, right? Because they just switch spaces. So if T is 1 over F, then TA is equal to 1 over 0.25, which is 1 over 2.5 s to the minus 1. Hertz is the same thing as seconds to the negative 1. So you can see if you have that in the denominator, it comes up to the numerator and becomes seconds. So TA is 4 seconds. And the period for B is 1 over 0.5. So therefore 2 seconds. All right, and finally, part D, write the equations for A and B in terms of sine and cosine. So you can tell by looking at it, I mean, cosine, we know that when time is 0, it has its maximum value, and that is exactly what B is showing us. When time is 0, it has the maximum. For sine, when time is 0, you have a displacement of 0. So A is going to be modeled by sine, B is going to be modeled by cosine. So let's start with A first. Okay, so A, we said we're going to model with sine. Now, this is the formula for the displacement of a curve. X is equal to A sine, and usually we say omega t. But in this case, we're not dealing with omega, we're dealing with frequency. So we'll write it as 2 pi f t. And because this is for A, we're going to say x sub A sub A, f sub A. Okay, so everything is specific to curve A. Amplitude of A we found, it's 2.5. So 2.5 meters, put that in brackets, sine 2 pi times f. F is 0.25, right, times t. So 2 times 1/4 is 1/2. 2.5 meters, sine pi over 2t. And there is your expression for XA. Okay. Now for B, we said B was modeled by cosine. Okay, so same thing, XB is equal to AB sine 2 pi FBT. plug in your values. 3.5 meters. Oh, guys, sorry, I put sine, didn't I? Should be cosine. Cosine. Cosine, 2 pi, frequency is 0.5 times t. 2 times a half is 1. So this actually just simplifies to 3.5 meters cosine pi t. And that's it for this video, guys. I hope you enjoyed it. If you do have questions, be sure to leave them in the comments section below. Otherwise, I will see you guys all tomorrow for video 136, Simple Pendulum 1, posted at 12 noon. What? Wait, who's back to school? Pumpkin pie recipe. Okay, I'll save that for Halloween. Guys, so that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me, which, by the way, I post every weekday at 12 noon. So be sure to be on my channel at that time. As always, if you missed my videos from the past, be sure to click over there on the right. You'll see some of my latest videos there. And other than that, guys, I hope you enjoy the rest of your day. Peace.